Wait a minute. No way you can do all that in like 30 minutes? Challenge accepted. No script, no multiple takes. We're just going to go beginning till end, me solving one question in 30 minutes for ML system design interview. So the question we're going to tackle today is design a feed for YouTube recommendations. YouTube has billions of users daily, and it doesn't matter if it's 500 million or 3 billion. And, each one of them, most of them probably don't post, but they're probably a good 100 million or more order of magnitude new pieces of content posted to YouTube every day. We're going to ignore the shorts for the purposes of this and just stay with long form content. So we got a boatload of those. Also, the recommendations on YouTube, unlike some other social networks, can go back quite a while. It's still relevant to me to get recommended things from a few years back. And so, yeah, there's going to be some cutoff. We can think about it in terms of exponential decay as it gets further and further away. And we could model that, or we can just say we're going to cut it off at a certain point in time. What I need to predict at the end of the day is, what I need to produce rather, is a feed of about, let's say, a couple of hundred videos that have the first one of which is probably the most relevant, and then they decrease in relevancy a little bit, but still remain pretty relevant to the user. Does that sound reasonable? Okay, thank you, Mr. Interviewer, or Mrs. Interviewer. Okay, so if that's what I'm predicting, I would need to know, so I know the scale now, but the other thing I would like to know is the latency. So there is this property of the recommender systems that, or really any ML models, that you could have latency, you could have, so by that I mean tight latency, you could have scale, and you could have accuracy. And any two of the three you're welcome to have. But I think the problem here is that this is business critical, so we have to have accuracy. Latency needs to be quite tight, because if you've ever sat in front of your computer for a couple of seconds while the page loaded, that's not acceptable. It's got to be sub-second, probably 100 milliseconds or so. Again, order of magnitude. And then scale, we have a tremendous scale. So what I want to do is I want to rank all the posts, but unfortunately I can't do that easily here. So we're going to need to talk a little bit about how to handle that. The other thing is the post, I'm just going to assume the actual item, I guess, is a video, some description, maybe a thumbnail, and a title. So let's just, for simplicity, assume that those four pieces make up an item. And then let's assume that we have a system in place today because somehow we're a going concern. So there definitely is some system in place, even if it's just random, but we can compare against that to see how well we're doing. And what we're after is engagement, right? So likes. I'm going to say that having watched maybe 30% of the video is maybe an engagement point. Maybe we have a couple of those. I don't really want that to be a continuous variable. I would rather have it be watched, 10%, watch 30%, watch 50%, watch the whole thing, something like that. All right, I think we're ready to jump into the rest of this. Does this sound like I understand the question? Are there any nuances that I might have missed? Okay, thank you very much. So I just want to go through and let you know kind of how I'm going to think this through to give you a mental mind map of what is going to happen, and just to kind of align on this, right? So first I want to go through big picture architecture of this, and then we're going to go into some data considerations, followed by modeling, if only I could spell, and then followed by deployment. So deployment to me is everything that happens after you have a model that you're quite comfortable with. So if that's okay with you, let's proceed. And yeah, I'll cover things in this order. So for big picture, what I really want to do is I want to make sure that we're covering this problem that I've identified here, right? So this guy right here is going to give me some problems here because I have kind of the need for all three. So we're probably not going to solve all three of them in a single model, and that's okay. So, oops, I'm going to get over to the side here. So a user submits a request for this feed. I have some service here. The service will talk to the machine learning model. And what it's probably going to first ask for is it's going to talk to service. And this is going to be our candidate generation model. So what I want to do in order to solve the triangle dilemma that I showed is I want to split this up into multiple stages. So the candidate generation stage in particular really only cares about the scale and the latency. We are going to have some false positives that this identifies, and that's okay. We're going to optimize it to identify as many true positives as we can, and we're going to go from, maybe a billion, or like there are billions of posts. I'll draw that in a minute. To maybe a couple of, so like the input into this is maybe a billion posts. Again, if only I could spell. And the output of this is maybe a few thousand, maybe 1,000, I don't know, order of magnitude, right? And then I can have another stage, which is my ranker. So this is what's gonna determine the relative relevance to the user. And this ranker is gonna go from thousands to thousands because that's a ranker. Rankers don't kick things out. But yeah, so here we have a ranker, but this 1,000 is now arranged in order. And then I'm going to have some non-ML system. I'm just going to represent it with the oval for no real reason. And so this is like business rules. So this is, the most basic version of this is we can just cut off that 1,000 down to a couple of hundred that we need. But we probably want to take care of diversity. Like if all of them are videos from me, that's terrific. We should keep that. But if all of them are videos from, I don't know, somebody else, then we only need like one video from that creator in the feed. And yeah, so business rules can also enforce a couple of other things here. And actually, now that I think about it, we probably want to have business rules kind of everywhere. So even here, we might want to start enforcing some diversity, maybe not, but it's good to have some business rules here. And here we can, right here, we could have business rules for like, let's say the user is 18 years old or younger. We don't want to surface them content that's like 21 plus. Let's say the user has never watched a YouTube video in Japanese. We want to maybe not serve them content in Japanese, right? So this just helps us basically things that we already know, we can eliminate. And for anything else, we pass that to the candidate generation. So there is another path here, and there's another type of user, or another user who generates the post. And so user generates a post, and I apologize. So post, that also goes through some sort of service, but we don't care about that much right now. What matters is that the moment the post is generated, I don't want to take up any of my precious time once we get to this candidate generation stage. I know, or post is a video in this case, I guess. So I don't want to take any of my precious time here. I want to encode it and store it as an embedding here at generation time. I guess one thing I didn't ask that I didn't clarify that I probably should have is I'm assuming that it's okay that a video is not recommended right away, that there's some encoding step here. On YouTube, it takes a little minute for it to go live. Is that a reasonable assumption? Okay. So yeah, so this gets stored as an embedding. And it's from those embeddings that we start our exploration here. The user also has activity that also goes into offline path. It could be either user, but no, let's not do that. Let's do another user. And now, like, there's activity, right? So like interacting with different videos, like doing all sorts of stuff. And I think we're going to store user embedding as well. So both of these would live like in an embedding store, or basically vector store. So there's some vector store here. And these are not static things, so maybe we recalculate them every once in a while, maybe once a day or so. I'll talk a little bit more about how we deal with them in real time. But overall, I think for the system, we do that. We just recalculate them every once in a while on a cron job. And then I'm going to leave kind of that part of the system right here. It's in the real-time portion, so this separates the real-time below it from things that happened before the feed was recommended. We'll talk about this box when I talk about data. And this box is meant to, like, it's some sort of, real-time update. The idea here is that if I go on YouTube specifically to find a way to fix my car, and it's 1998 Toyota Corolla or something, and I watch a bunch of those videos, the algorithm should probably adapt quicker than we can retrain these embeddings. And so we want to make sure that we capture that signal. So there's something we need to do there, but we'll get there in a minute. And then from those business rules, in the end, we basically generate about 1,000 posts. Oops. And those posts go back to the service, and the service communicates it back to the user. So there's not a way to do a two-way arrow here, sadly. So it goes back to the user. Okay, so and this round trip should be really fast. So again, in the first stage, in the candidate generation stage, we're prioritizing for scale and latency. And in the second stage, we're prioritizing for accuracy and latency. But at that point, the scale is not too big. It's just a few thousand. And here, we can say, we're getting hundreds back to the user. Yeah, how does that look? Is that similar to what you're thinking? Okay, good. Okay, so the good news is we have two of these embeddings calculated entirely offline to the system, so they don't eat into our latency budget at all. So let's talk a little bit about data considerations. So the first thing that I want to talk about with data considerations is our labels. So obviously hard to do machine learning without any labels. So where do our labels come from? Well, we already talked about how we have a system currently, and we talked about how interaction is what we're trying to prioritize. And so if interaction is what we're trying to prioritize, these could be essentially likes. If you don't know about likes on YouTube, take a look at the button below. It has a thumb up. And if you're still here at this point, why not put a like on this video? It might help out the algorithm. Maybe watch time, right? So we talked about that. Bucketed. There are probably a few other signals, like when you get to an end screen, did you click on the thing on the end screen? Are you still watching that creator? Did you click a follow maybe? Which, like, if you're not following this awesome MLE path guy, you should be. Yeah, so there's a whole bunch of signals here, and I would probably do some classification problem here. So this is binary multi-label classification. The reason I like to have multi-label, so I probably would train for each of those labels, and then I would train overall for engagement somehow. But even training for each of those labels would already give me a lot. And if my product manager comes to me tomorrow and says, you know what we've decided is that we really need to prioritize likes, then I can very easily tune the system. So those are my labels. So those are my positive labels. My negative labels are a little bit trickier here. So the trick is that, obviously the really bad answer would be to say anything that the user hasn't clicked on, they don't like. Well, that's not exactly true because they didn't even see most of that content. So a little bit better is to say anything that appeared in their feed but they didn't click on. But I think better yet is if we go through the chronological feed. So 1, 2, 3, 4, right? Like let's say we have a very simple feed with 4 videos suggested. The user clicked on 1. That's a clear positive sign. The user didn't click on 2. We're going to count that as a negative. The user clicked on 3. So we're going to count that as a positive. The user didn't click on 4 or anything below that. Well, that means I don't know anything about number 4. And so I probably wouldn't include that into my labels at all, or I would mark it as a separate class and not mark it as a negative. So the downside to that is we're clearly operating with a lot less data. The upside is that the data that we're operating on is a lot better. The other upside is that this is a highly imbalanced problem. Even if I only go off of this is still probably imbalanced at least 10 to 1. Because most of the things on your feed you're never going to click on. But 10 to 1 imbalance is a lot easier to deal with in machine learning than like a billion to 1 imbalance. So if there are billions and billions of pieces of content, you've only interacted with 10 of them, that is actually pretty hard to deal with. So we could do some subsampling there or some negative sampling or whatever, but we might not even have to do that if we go off of a strategy where we only go to the last piece of content you interact with. The other consideration here is that the YouTube feed is a square. And so there's, video here, video here, video here, video here, and then underneath. And so we need to be a little bit culturally aware here. For most Western cultures, I believe the pattern is left to right and then up to down. And but we have to be aware of languages like Japanese and Hebrew are read differently, and because of that, the scanning patterns in the cultures that speak those languages tend to be a little bit different. So that's something we have to keep an eye on. So those are my labels. Now for features, the main question is where do we get features? And here clearly videos. We have users, and we have interactions between them. Now, in a system like this, first of all, you'd probably have 10, 20, 50 stages. I don't know, you probably won't have 50, but you'd probably have, 10 ML stages. And notice how when I talked about big picture diagram, I really focused in on 2. I think, for the purposes of time, that's probably the best use of our time. And also, it allows us to demonstrate some concepts that would be useful to anything else. Likewise here, let's just talk about a couple of features for each section rather than going into a lot of depth. Does that sound good? Okay, great. So for videos, obviously we already have our, the 4 things that I mentioned. They might have tags, and they might have number of likes. And number of likes, you can't do in absolute terms because a video that's been alive for 30 seconds is probably going to get way fewer likes than the same video that's been alive for 100 hours. So likes at some time, at 1 hour or whatever. The problem with having it be at 1 hour is that initially you have to train that embedding with a none, and then you have to retrain it. But that's life. That's how we live. So for tags, there are way too many of them to do one-hot encoding. So I would probably do something like, embeddings are pretty good. And here you could probably use off-the-shelf embedding. Or we might want to train our own because hashtags are sometimes a different beast from general purpose language. So probably train our own embedding. For the number of likes at a certain time, so we have two problems here. One is while likes are an integer, and we can theoretically put an integer into our model, there's a pretty wide distribution of what they could be. So I don't want to deal too much with the outliers, so I want to standardize it somehow. Now, how to standardize it? You could standardize it in a naive way by shrinking everything down to -1 to 1. There's really no magic to that, though, right? Like, what we're trying to do is we're trying to just make sure that things are basically on the same scale. And for different creators, different numbers of likes mean different things. So for a creator like me, 500 likes on this video would be amazing. For a creator like Mark Rober, 500 likes would be pretty disappointing on any video, honestly. And so let's maybe standardize this by the number of likes an average video gets, or the number of followers, or the average number of views, or the number of views on that video, something like that. It won't quite be up to 1. It might get into the tens even. That's okay. I'm not too worried about it getting into tens. I don't want it to get into billions too fast. So for users, we can have several features here. So age is interesting, maybe. And then, maybe for users, we also have a graph of, or we don't even have to have a full graph, just like probably first connections. There's no concept of connection on YouTube. So like follows, maybe. And this I would also probably encode in an embedding of some sort. For age, I would bucketize it, and then I would represent it with one hot encoding. The reason for that is we're in the business of selling ads, and ads actually have very strong age demographics. So you usually sell ads to 18 to 24-year-olds or whatever. And so there's a finite number of those buckets. I'm not too worried about sparsity. So, we could do that. And then interaction between them, this is where a lot of our labels are going to come from. So I don't know that I'm going to cover that much more. And then once we have all this data, we need to split it somehow. And I'm going to propose that we do train, dev, test, split. The reason you need that dev set in particular is because you don't want to overfit on your test set. So on the train set, you train the model. On the dev set, you tune hyperparameters. And on the test set, you only do the evaluation before the model launches to production. Yeah, and for the split itself, since the seasonality is probably weekly, the content that you look for on weekends could be quite different from the content you look for during the week. I would say that we need at least 2 weeks in both dev and the evaluation set, the test set, so that if something funky is happening on Monday, we can go and check the other Monday and make sure that that's where it's coming from. Now, the downside to that is that you miss out on about a month of data in your training set. But, the moment that your model hits production, it's going to see data it's never seen before anyway. So you need to be robust to that. And the reason we need a temporal split here is because certain things trend based on news, but then when the news dies down, the kinds of people it attracts are different, and also the patterns of interaction are quite different. So yeah, temporal split here is quite useful. And then I just want to go back here real quick and talk about, kind of in transitioning to the modeling section, the real-time update piece. But before then, do you have any questions on what I just covered? Okay, great. I have a great interviewer. They have no questions today. It's almost like talking to you or myself. All right, so for the real-time updates, this again is there to solve the problem of I came on the platform to solve a particular thing. And so rather than generating all the candidates, you now really should be shifting towards whatever I came there for. And this is cached for a short amount of time. And so the way that we can do this is we can have a basic MLP that we train with, the input is the embedding. So for the user, it could be the user embedding. For the post, it could be the post embedding. What changed? So a vector of what changed. And the output is a new embedding. So basically, it's a slightly modified embedding that we had in the first place. So it's sequence-to-sequence learning. A basic MLP would do this quite fast. I'm not too worried about latency, and then we throw it away at the end of the session. And then next time we just read back from the initial embeddings. Yeah, so that's what I propose. And then we retrain those embeddings once a day or on a slightly longer time scale, so that, you know, the one time you went in there to look at washing machines, you didn't just ruin your feed forever with washing machines. So, okay, so for modeling, we basically already have the outline of the two-tower model. We have the user tower and the, so two towers, the user tower and the video tower, the item tower, whatever you want to call it. So basically when we have these embeddings right here, what we do is we take a dot product or somehow get them into the same space. We find a distance measure. So this needs to be, the distance metric needs to be quite simple because this is something that we want to calculate fast. So even cosine similarity would probably be fine, but I don't know, like some distance metric that's pretty easy to compute. And what we do is we look for the videos that are closest to the user in that space. So initially we look for like a couple thousand of them for the candidate generation so we can pass them on. And then in the ranker, we use something similar. But first, let me just go back and say how we're going to look for similar things. So approximate nearest neighbors is what I would pick. We could do nearest neighbors, but that takes up more time, more resources. And it's, you know, we need to go fast here. So approximate nearest neighbors is the right algorithm here. Whereas in the ranker, you know, I would like to use the same basic philosophy and just do embeddings plus ANN, but I would probably do something like this real-time update piece here, but instead of real-time update, I would give it more features. So this embedding could be quite simple, and then here the embedding could be a little bit more complex. So we enrich that embedding and then do the same thing. And what that would do is it would also allow us to do distillation back into our candidate generation model, so we can train our ranker, which is going to be the more advanced model first, and then distill the learnings into the candidate generation model. This is a classifier essentially. And and the most important thing is not to miss any true positives. So what we're going to do is we're going to pick recall for our metric here. And for a loss, you know, there's a modicum of imbalance here. I think a log-based a log loss, normalized cross entropy maybe. Normalized cross entropy would deal with the imbalance a little bit better. So let's put normalized cross entropy both here and here as our loss metric. And then on the ranker itself, we can't use a metric like recall. I mean, we could, but it wouldn't be applicable. So instead, I'm choosing between MRR and NDCG. MRR is better when you're trying to guess the first answer right. You don't really care about the order beyond that. Since we're trying to get an entire feed that's basically correct, NDCG is my metric of choice here. So that's what I would start with, is NDCG and recall. Yeah, and obviously, like, if anything goes wrong, you monitor them and you adjust, but those are starting points here. Yeah, any questions on modeling? Okay, yeah, thank you. Yeah, so that gets us a model. We have our train and test splits. We can, yeah, and if we train the ranker first and then go for candidate generation, then we can use distillation to be a lot more resource efficient. Okay, so how are we going to launch that to production? So for production, we need to run an A/B test. We need to canary deploy this because other deployment possibilities, such as blue-green deployment, for example, require us to stand up a whole other system to deploy alongside ours. And at these scales, it's just cost prohibitive. So A/B test here works well. We don't really have anything that like lives depend on it. If we did, if it was like unethical to make the wrong choice, for example, then I would recommend bandits instead, because bandits can converge to a solution and then start recommending more content from your B system than A if B is truly better. But here we have time to run an entire A/B test. And honestly, yeah, I think that's as good a solution as any. We do need to stratify that by users. So the same user has to be either in the A group or the B group, cannot be in both. And then we run that for a while. We need to get some statistics of the magnitude of the effect versus how long we ran it and on how many users. We measure online metrics, which, you could go with the same things. You could go with engagement metrics as online metrics. You could also go with just how long users spend on the platform, or the number of ads you can show, or something like that. Number of ads is probably a little bit too abstract, so let's stick to the same engagement metrics. But yeah, time on platform is also possible here. And then once we deploy it, we need to make sure we retrain it every once in a while. So for a model like this, content is uploaded all the time, things are happening all the time, so maybe every few hours I would retrain it and monitor normalized entropy. And as long as that's trending in the right direction, or at least staying constant, I would be launching newer and newer models every 4 hours automatically. And if not, then, the first time I'd probably let it go. The second time I'd probably get alerted on the on-call. Speaking of which, I would probably monitor the inputs and outputs to every stage. So every ML model, even this one, needs to have inputs and outputs monitored. Outputs are usually my fault as an MLE. Inputs are usually the data team's fault. But I'm not so much caring about assigning blame, but I need to know what's happening to my model in production, and I will alert the right on-calls after that. So we can do that. And that's basically it. And I did not make it in 30 minutes, which is okay. You actually have about 37 minutes or more, even like 40 sometimes, to cover everything in this interview. My interviewer was incredibly kind to me and didn't really have a lot of questions to direct back at me. But I feel like as long as you keep the interview moving, and as long as you give your interviewer a perception that you'll get there at least, right? So the reason I outlined early what I'm going to say and when is because I don't want my interviewer in this stage being like, okay, what is the model here? Or what is the model here? I want to make sure that is covered later and that their brain is at rest, that it will be covered later. Also remember that you don't need to hit every single point here. You just need to make sure that you give your interviewer enough. Please do watch the ML system design video. It'll really help you solidify the ideas I talked about here.